Hey there, and welcome to your Unit 6 Part 1 review video. We're going to go ahead and go through these slides and kind of get you up to speed. A lot of this stuff we've already gone over, so this is going to just be familiar for you. You may want to get your Unit 6 packet notes out and your Unit 6 speed dating stuff out, just kind of make notes on the side. As we get closer to the national exam and we start building our review sheets you're going to put on the wall during the exam, we'll kind of condense this even more. But the more you hear it, the more that you can have these facts ready to go in your head so that when you're asked to do things like discuss and propose and justify, you're ready to go. All right, so let's go ahead and get this started. All right, so I'm going to skip really quickly through these CED slides. These are the course and exam descriptions. These are in a document I've already uploaded onto Canvas. This just gives you a begin with the end in mind. My suggestion is when we do the PowerPoint slides like this that you take a look at this stuff in advance. I don't know that I have them loaded on every single PowerPoint. If I don't, make sure that you take a look at these in the document before we get started. If you need to pause here, of course, you're welcome to. All right, so this first topic is just very basic. It's getting you to understand the difference between renewable and non-renewable resources. That is based on a human time scale. Do these things replenish themselves within a couple of human lifetimes or within our lifetime? So when you look at something like the sun, it's actually more than renewable. It is perpetual. Yes, I know eventually the sun's going to go out, but not today. Water is something that pretty much runs all the time. Geothermal is something that goes all the time. Biomass, which is plant life, as long as you don't cut it down quicker than it can regrow, it is also renewable. There are 4 non-renewable resources you need to know of: coal, petroleum, natural gas, and uranium. Those things reform so slowly that it is beyond the human time frame. Uranium, as a matter of fact, all of it is breaking down over time. We'll never get that back. As you know, coal, petroleum, and natural gas are all formed from plant and animal matter that has undergone time and pressure and heat to become those sources, and that takes millions of years. All right, so again, when you're talking about most of these resources, even the non-renewable stuff right here, fossil fuels, that is, it comes from the sun because it comes from plant life. Anything that comes from plants, anything that is wind-based, any ocean currents, not all water. Remember, fresh water in rivers usually runs because of gravity, because there is a change in the incline of the land. But biomass, obviously solar power, wind power, ocean currents, all of those things are driven by the sun. The only things that really aren't driven by the sun are going to be, again, it's not listed here, rivers, because they run on an incline. That's because of gravity, nuclear energy, and then geothermal energy. All right, so topic 6.2, this is about global energy consumption. If you haven't noticed, developing countries use less per capita than developed countries. Remember, the word per capita means per person. There are some other trends we're going to tie together with human populations in terms of energy use. And that's basically right here. Developed countries use commercial energy sources. They buy them, oftentimes from other places: oil, coal, and natural gas. Developing countries, they do subsistence energy. If there is a water source nearby that's running, they can use hydropower, but that's usually they're not creating electricity. It's usually they're turning a water wheel to like grind grain. You can see here that sticks have been gathered, biomass. It's basically, sometimes they burn coal, but it's basically stuff that's just around. Okay, so be able to make those connections between developed and developing countries. Think about how energy consumption relates to human population dynamics. So again, if you are given an age structure diagram and you are asked, what kind of energy sources do you think this particular place is going to use if it is a rapid growth, which is this left-hand side one, It is a developing country. They're going to use largely what's in-house, which is largely going to be biomass. They're largely using it directly as heat, light, heat or light, basically. And then if it's a developed country, that's where you're getting into the coal, oil, natural gas, nuclear power, because that requires money to either to purchase from other places or to create the power plants within the country, to use those largely to create electricity. Electricity not as much of a direct resource in developing countries. Be able to connect that to aid structure diagrams. So if you are in stage 2, you're a developing country, you are most likely using, again, biomass and coal, but again, directly for heat and light. If you are a developed country, which is stage 3, that is where you're starting to convert to things like coal, oil, natural gas, and nuclear power, hydropower, in order to create electricity. Okay, so as industrialization increases, energy use increases and sources of energy change. That's what this is showing you right here. Now again, remember, this is a video. You can go back and watch this as many times as you like. You can also pause it whenever you like. This is a skill that you're going to have to be able to do, be able to read graphs. So notice trend lines here. And what this also tells you is at what point in, the demographic transition took place. Okay, so patterns of energy use. We went from wood to coal. Nuclear wasn't developed until the 1950s. The reason the 1970s saw a dramatic dip in oil was because we were kind of going through an oil war with Saudi Arabia. They basically stopped exporting it, and it costs a lot of money. Today it's oil, natural gas, and coal. In that order is what we use them for. Remember, oil is largely used to drive transportation and industrial purposes, like, agriculture. Natural gas and coal here in the United States is largely burned to create electricity. Natural gas, of course, can also be used as a cooking source and a heating source within people's homes. There's been an increase in natural gas because of that technology called fracking, which we will get to in another video. So here, why are we looking at this? Because this basically tells you the United States runs on non-renewable resources. Why? Because we do. A question that you could be asked would be, what are the pros and cons of switching to renewable? Pros are largely immediately could be economic. You are creating new jobs because you'd have to create an entirely new infrastructure that did not pull from just one of these renewable energy sources. It would pull from a lot of different energy sources because, wind doesn't blow all the time. Hydroelectric may not be nearby. So solar's not on all the time, obviously. Wind. So you have all of this that you would pull into kind of a multi-input infrastructure for electricity. So a pro would be economically you'd be creating jobs. A pro would also be that at some point, as we're going to see with renewable energy, these end up having a lower impact on the environment for a variety of reasons. The downside would be whenever you are creating anything that humans are using, you have habitat destruction, because you're building roads, invasive species can get in there. So, loss of biodiversity, the usual stuff. All right. This is a slide that we went over. Highly populated areas aren't super fond of burning coal because you don't like having air pollution where you live. Just think about how trends work. My concern with this exam being so short is that you may have some brain freeze. So we're going to work on making you mentally limber so that when it comes to the national exam, you're not like, a deer in headlights. All right, so when you're looking at this graph here, what you should notice is that residential, which is you and me at home, we only use 21% of the energy in the United States. So what does that mean? Although making good choices at home to reduce your energy use is a good thing, light bulbs that use less energy and last longer, energy efficient appliances. Side note, all of those things will save you money too. Hybrid cars, that stuff. It is not going to make the dent on energy consumption in the United States that we really need to. And even this transportation has a tendency to be more commercial than residential. We need to push for our corporations and industries and agriculture to make better choices as well. How do you do that? You incentivize with things like tax cuts, subsidies. You help to partially pay for these conversions, or you put in penalties. If you don't do this by this date, then you're going to have to pay this much money per day until you think it's important for you. So again, this is not the kind of stuff you have to memorize. It's just the kind of stuff you need to be aware of in terms of answering questions on the national exam. All right, so there's the CED stuff we're going to cover. Okay, so these are all things for you to consider when you're looking at fuel types. And this is probably not a complete list. So when you're looking at an energy source, make sure that you don't just zoom in on the stuff that's right in front of your face. Consider all of the things that you don't see. What kind of habitat destruction took place before the coal even got to the factory? Great, you're burning stuff. Where is the ash going? Is the energy source appropriate for the job at hand? What energy source is appropriate for the job at hand? As an example, if you're trying to provide energy to a desert town, obviously hydropower is not going to be something that you're going to pick. If you're in a developing country, they're probably not going to use nuclear power because those plants are very expensive to build. So again, when you're looking at this, make sure that you're seeing the stuff that's not right in front of your face. So if you need to pause and kind of read this, get this in your head before we move on through. Now, the Unit 7 stuff that we're currently doing talks more about this pollution, so it's kind of a nice loop back. We're definitely tying these two units together. All right, so wood. Wood is mainly firewood and charcoal, but animal dung is also considered to be a biomass because when animals, herbivores, eat things like grass, they don't digest it all, so they poop part of it out, and that's what you can dry and burn as a fuel source. Again, often used in developing countries due to easy accessibility. There is this misconception that developing countries, everybody's happily going out and cutting down wood and everything's fine. Remember, again, it's a very hard existence, and people are not concerned about using things in a sustainable fashion. So you notice that there are spreading rings of deforestation around villages because you're cutting down wood faster than it can replant itself, as an example. Okay, so remember that there are 4 stages to the creation of coal, and the first is peat. Peat, actually, as you can see here, can be cut into bricks, and there are places in, I want to say Ireland. It's one of the islands around England where they've actually used this to build their homes because they've just got peat everywhere. You can also burn this in the same way that you can burn charcoal for energy. By energy, I mean heat and light. Nobody's boiling water to create electricity with this stuff. So remember, the 3 types of coal are lignite, bituminous, and anthracite. The more you move from left to right on this particular page, the less moisture content you have, and the more condensed the carbon content is, which means anthracite is the kind of coal everybody wants. What determines what kind you have? It depends on just basically your geography. It's luck of the draw. What kind of plants and animals died millions of years ago on that particular part of Pangaea, and did they end up in a place where they could go down into the ground and be subjected to millions of years of heat and pressure? So the reason certain places have coal and other places don't is just the way it worked out. Okay, so Natural gas, you know, is mostly methane, CH4, so make sure that you know those chemical formulas. Um, and we talked about tar sands. This chapter just kind of talks about what they are. We will talk about in subsequent sections, not chapter, this section, excuse me, subsequent topics, why what you're looking at is bad, although I'm sure that you can kind of just look and see. Okay, so I've already put this timeline in order. The reason this is important is this first thing. Energy is lost at every step. So just because you are like, haha, bituminous coal, it doesn't mean that 100% of that energy that's in the coal is going to end up charging your phone. What that tells you is that these processes are also incredibly inefficient. Not only do you lose energy at every step, you all in the actual, and it's not that the coal goes bad. It's that when you extract the coal, remember you're quote unquote paying for it by the energy that you're using to power your vehicles to dig it out and then to take it to the processing plants and then process it and then combust it. So the coal still has the same amount of energy, but you are paying in other energy that you have purchased to get this stuff where you want it to be. And remember also, every step of the way, there's also habitat destruction and loss of biodiversity, and sometimes pollution. It just depends. Okay, so EROI, this is something that I did a spectacularly poor job of teaching the first time. Don't worry about calculating those numbers. Just be aware of this concept that just because you have, let's say, 1,000 joules of energy in a piece of coal, doesn't mean that you end up with 1,000 joules of energy from that coal. Not only do you lose a bunch of heat when you burn it, think about all of the other energy you had to invest along the way to get that coal to your electricity plant in the first place. If it takes more energy to harvest and prep than it does the energy that you get out, even though it's there, it's not worth it. Okay, so CAFE standards are a really great way of showing how laws work. When cars get more miles to the gallon, they need less gasoline, so therefore they produce less pollution. We have less habitat destruction, less loss of biodiversity in the harvesting and the refining of this whole thing. So there is a, sorry, making a note to myself. Laws work. And so basically, remember, CAFE standards were, administration said, hey, you have all of these cars and trucks. The average has to be, of all of your types of cars, 32 miles to the gallon. For all of your vehicles, it has to be about 27 miles to the gallon. And for trucks, it has to be 23 miles to the gallon. So that means for every Hummer that you do, you need to do a Leaf. A car that gets an extraordinary amount of miles per gallon. Now, would it be better if every car was at least a hybrid and got 45 miles to the gallon? Sure. We're not there yet. So this is kind of pushing people in the direction of fuel efficiency. Okay, so do realize that electricity itself is clean. It is the production that is the problem. And it is a secondary energy source. Nobody's plugging in their phone to charge into a piece of coal. Okay, understand how an electrical grid works. Every time you see electricity flow through a wire, you're losing some energy as heat. So that means by the time it gets here, I mean, think about that coal sitting in the ground. Think about all the energy that you had to take to get it, to harvest it, to take it where it's refined. You wash some of the impurities out, you take it here, you burn it, boiling water, turbine, generator, electricity, goes through all these wires and then finally to your house. Not very efficient at all. All right, so some power plants have figured out, hey, we've created all this extra heat. What's the deal? So what they do here is they combust natural gas instead of coal, and they use the waste heat to go ahead and boil secondary water because it's still really hot. The heat that kind of just comes pouring off. So they've got two generators going, two turbines, two generators, two electricities. So basically, two sources of electricity, sorry. So basically this extra source of heat that people were just letting just go, these natural gas power plants have figured out how to harness it. Why is that important? Because it means that you're harvesting less to make more electricity. Are these numbers that you need to know? No, you just need to understand how power plants work. They usually have to run all the time. Another reason that we use coal-fired and natural gas-fired power plants is they put out a lot of power. They really do. Stuff like wind, you can see, has maybe a quarter, a little bit more, a third of what you can get out of a coal-fired power plant. So again, if we were going to use renewable resources, we would have to have a lot of them kind of jacked into our electrical grid. And it might be that we never get away from coal completely, but we definitely reduce how much we use from day to day, coal and natural gas. Cogeneration is, again, where you don't let that heat go to waste. A classic way of using that heat is, again, to just heat your building. Another way is, I'm going back here, you can see that the heat is still perfectly hot enough to boil a secondary source of water to create, to turn the turbines, to turn the generator, to create the electricity. All right, so these are, again, things that I'm not sure whether or not you have to memorize. These are more multiple choice type questions. We will still make sure that they're on your little cheat sheets. But just be aware of what comes from what country. Why do you care? Because it tells you why the United States uses so much coal. It tells you why, despite what we might politically think about these countries, why we still have a relationship with them. Because the United States uses a heck of a lot of petroleum. Notice that Canada has tar sands, which explains why the United States is so interested in refining them, because we're literally right there. This is back when we used to harvest natural gas the old-fashioned way. Fracking has made natural gas here in the United States a viable option. And then you can see uranium very much is a Australian thing, although there are a significant number of plants in Japan as well. Okay, so that is the end of our presentation, and let me just figure out how to get out of this. And there we are. See you later.